Now, moving on to something that you already know and you've met previously, but just to mention it and as a reminder, data presentation. And data presentation is the form in which data is presented for clarity. And usually this takes the form of numbers, tables, graphs, or diagrams. Let's consider some diagrammatic slash tabular ways of presenting data. The first type is tally charts. And let's say you are a grade 1 teacher and you go around the class asking them what is your favorite pet, and as the class answers you make a tally mark against the picture of the pet that they prefer. And when you collect 4 tallies and you get the 5th, you put the 5th mark across, so you end up with groups of 5. This represents a 5. So it would be easy to count in 5s, and you will know the number of the people that prefer cats, and so on. This is a form of a primitive table. But in the end, you can look at the totals, and you can tell that the number of students in this class is 20 students. Another type of data presentation technique is pictograms. In this case, we are considering the sales of a canteen of cupcakes. And let's say that they are representing each 6 cupcakes sold by the picture of 1 cupcake. So we can count on Monday there are 5 cupcakes, and that tells us that they sold 30 cupcakes on Monday. Here we have 2.5. That means that they sold 15 cupcakes on Tuesday. And as you can see, the data here has not been processed, neither here nor in the case of the tally chart. This data is quantitative and it is discrete because we are talking about the number of cupcakes or the number of students that like certain pets. Another type is the bar chart. Consider the cars sold in January by a certain car dealer. We draw the bar chart. On the horizontal axis, we put the names or the makes of the cars. And on the y-axis, we represent them by the numbers. We make sure that the bars have equal width, that there is a space between each bar and the next, and we can read the total number of cars sold from the vertical axis. Again, here the data is quantitative and it is discrete because you cannot sell 42.5 cars. You either sell 40 or 41. And the number of cars sold is sometimes referred to as the frequencies. Again, here if we look at the 30 cupcakes, they may be referred to as the frequency, or here the frequency of people who like pets, the frequency rather than the number is just the 10. Remember that in this case, in the bar chart, your variable is the answer to the question in the survey. What was the car that was sold? BMW or Buick or Toyota. So your variable in this case is the names of the cars. It is not the number. So your variable here is a qualitative variable of the nominal type. Also, we have pie charts. And if you consider a pie chart, for example, in this case, the number of Palestinian houses demolished in 2013, you have sectors in the circle representing the number of houses in East Jerusalem or in the West Bank. Now, how do we find the angle of the sector? In this case, the total number of houses demolished is obtained by adding 172 plus 95, which is 267 houses. If we know this total, and we know that 95 houses were demolished in East Jerusalem, we calculate the angle here by dividing 360 in the ratio of 95 to the total, which is 267. So you will calculate 267 times 95, sorry, mistake. You will calculate 95 divided by 267, which is the fraction of the houses demolished that is in East Jerusalem, times 360 degrees, which is the full angle. And if you calculate this, you'll find that it is 128 degrees. So this angle here is 128 degrees. And by subtracting from 360, you'll find that this angle is 232 degrees. Again, the number of houses is a quantitative variable, and it's discrete as well. Finally, we call this a stem plot or a stem and leaf plot. Let's say that this represents the ages of people at a birthday party. And the most important point to remark is that you have a key here, which is 6-3 represents 63 years old. So if you look at this stem, this represents the tens, and this 3 represents the unit. So we are talking that this represents a person that is 63 years old. Then this would represent a person that is 66 years old. This data has been laid out in full. It has not been processed in the sense that no loss of detail has occurred. We simply laid it out clearly, and we laid out every age. We have a 1-year-old, a 1-year-old, 2 2-year-olds, 3 1 3-year-old, and so on. Then 3 10-years-old, 2 11-year-olds, and so on. This way, when we look at it, one quick look will tell us that the majority of the largest number of people, well, the largest group is between 0 and 9, and the fewest are in their 60s. The data here is quantitative, but since it's been rounded, obviously it's been rounded, it's quantitative, continuous, but it is being dealt with as if it is discrete. The advantage of the stem and leaf plot is that it shows you the entire set of data without much processing. In the past 5 methods, we have shown the data as it is with little or no processing whatsoever. In class, we're going to start seeing how we process the data in real life.